So, like I was just mentioning, we're done learning new factoring techniques, at least for this class. I am going to show you one thing to just kind of pique your interest about a technique that you're going to learn in 1050. So I'll show that to you here, but this is the basic idea. Now, it's not that you have to memorize this list of factoring strategies line by line and just go through it 1 and then 2 and so forth. I mean, you should be familiar enough with it that it's not like memorizing, it's that you understand it, that we go through and we basically, the first rule is always take out the greatest common factor, and then we go through and we count the number of terms. So it's not going through line by line, but we say, well, take out the greatest common factor. Then if there are 2 terms, I know it's either got to be a difference of squares, a difference of cubes, or a sum of cubes. And these formulas right here, now take a look. Everybody watch, please. I left these partially blank on purpose. You should know these formulas. If there are 2 terms, it's got to be a difference of squares, a difference of cubes, or a sum of cubes. There is no other possibility, okay? At least that you're going to see. So if it's a difference of squares, remember, I said if it's a minus or a plus, we always put that operation with the first factor. And then this is going to be a plus b. So we've got a minus b and a plus b. I gave you the formula for difference of cubes. Down below, we want to write the formula for sum of cubes. Remember, it's just going to be the first one and the second one. Whatever the operation is here, that repeats here. Each one of these formulas only has one negative in it, so it's got to go in the middle of the next one. Perfect square of the first one, perfect square of the last one. Multiply the 2 of them together, and that one's going to be a minus because it's got to have that one negative in each one of them. Okay? And then if it's got 3 terms, we can factor it using the perfect trinomial square technique, which is a very good thing to be aware of because we're going to use that pattern in reverse in a couple of chapters. An easy type of trinomial, we just use guess and check. That's that easy question, what multiplies to be this number on the end and adds up to be the middle one. If it starts off with a number in front, if we've got a coefficient on the squared term other than a 1, then it's a more difficult one. You can use guess and check, or we use trinomial grouping. Okay, and I'll probably do one of those again today. But what's this formula right here? What's the only difference between the 2 of these?
Just a minus b squared.
Yep, it's just that it's going to be a minus b quantity squared rather than a plus b quantity squared. Okay, if there are 4 or more terms, we do this by grouping. If there are 4 terms, usually, but not always, we group the first 2 together, then the last 2 together. Okay, sometimes, like on the quiz that we had yesterday, you'll group the first 3 together and maybe leave the last one alone. Or maybe leave the first one alone and group the last 3 together. And it gets more complicated if we have 5 terms or 6 terms or something like that. But again, grouping, we group them together to make a greatest common factor. And then the last thing, we always want to factor completely. We want to break things down as far as we possibly can. And we always want to write down all the factors that we've accumulated. So if we took a 3 out to begin with, make sure we bring that 3 down and include it in the final answer. And like always, circle what your final answer is, because we've got a lot of work and a lot of factors floating around here. Okay, well, let's take a look at the first one then. So we've got t to the 5th minus 49t. First rule is always take out the greatest common factor. So if I do that, I'm left with t to the 4th minus 49. And then I look at that for a second, and I focus my attention just on this factor right here. It has 2 terms. Difference of squares, difference of cubes, sum of cubes. Certainly those aren't perfect cubes, so we've narrowed it down to, that's a perfect square of t squared. That's a perfect square of 4, so this is going to be t squared minus 7 and t squared plus 7. Don't forget the t. The t is just fine. T squared plus 7, is there any way that breaks down further? Nope, because that would be a sum of squares, if anything, and we don't have a formula for that. And what about this right here? 2 terms, is that a perfect square? Yes, but is 7 a perfect square? It's not, so we'd leave it right here. We don't worry about factoring with irrational numbers and radicals and stuff like that. So we'd be done right there. Okay? Now, I don't think, let's take a look at this. Yep. I didn't put any stars or any asterisks on any of these because I wanted you to look at them and know what you needed to do. But if you saw this problem on a test, and I wouldn't be surprised to see something like this on a test, immediately some bells should be going off because what's wrong with this? It's not in descending order. Okay, we always write these in order, either ascending or descending. Most of the time we write them in descending order. So I'm going to rewrite this as a squared plus 10a plus 25. Now, if you want to factor that as an easy trinomial, be my guest. But it would be much better in the long run if you knew that pattern for a perfect trinomial square, if you were checking that quite often, because this is a perfect square of a and that's a perfect square of 5. If you multiply those together, you get 5a, and if you double it, do you get 10a? You do. So this is a perfect trinomial square. I'm going to write a set of parentheses. I'm going to square that. I put the a there. I put the 5 here, and the only thing I need to do to get this right and write it in the most simplest factored form possible is whether I put a plus or a minus there. And how do I determine that? I look at the middle term. If that's a positive, I put a plus. If it's a minus, I put a minus. Good? Okay, let's take a look at the next one then. No common factors. We skip over the 2 terms because we've got 3 terms. And we're looking for a perfect square? No way, because it's a 6 and a 5. Okay. Is it an easy trinomial? Nope. It's a more difficult one. It starts off with a 3y squared. Sorry, a 6y squared. So this is a hard type of trinomial. So your choices are either guess and check or use trinomial grouping. Okay, I like trinomial grouping because I know it works every single time if it factors. And I know if I can't answer that one question, if it doesn't have an answer, then I know this is going to be prime. So I take the 6 and the negative 5 and multiply them together. Make sure you multiply them with the sign. That's a positive 6, that's a negative 5. They multiply to be negative 30. Don't just take the 6 and 5 and say 30 because that's a completely different question. Good? Okay, I need numbers so I'm focusing in on that number and that number right there. I need numbers that multiply to be negative 30 that combine to be negative 13. Multiply to be negative 30, combine to be negative 13. Okay, so here's the idea. Negative 15 and 2, but some people might come up with a 10 and a 3, right? Okay, but let's think about this. This is why it's important at this stage to stop and make sure you have the right answer to the question. Can you make a 13 out of these? Yeah, but they both have to be negative to make a negative 13. If you multiplied those together, you'd get a positive 30, not a negative 30. Good with that? So this is not the right answer. You would not use negative 10 and negative 3. Do these multiply to be negative 30? They do. And do they combine to be negative 13? That's the right pair of numbers to use. Okay? If you get this answer right, you're going to get the problem right. So I'm going to rewrite this. 6y squared minus 15y plus 2y minus 5. What can I take out of these two guys right here? I can take out a 3 and a y. So I'm left with a 2y and a minus 5. I have to take something out of these two right here. What can I take out of a 2y and a minus 5? Okay, I take out a 1. I can always take out a 1, and I always take out the leading sign. So I'm going to write that along with the sign. Remember, we stressed this. You need to write it properly. Write the positive 1. Don't just write a 1, because then it looks like multiplication. And that doesn't change anything on the inside when I factor out or divide out a 1. And then I look at the two of these. I've got two terms. I've got something in common. I've got a 2y minus 5. And I'm left with a 3y from the first one and a positive 1 from the second one. And that right there is the answer. No guess and check. No wondering if it's prime. No wondering if I got the right answer. Got it right there. Okay, are there any questions? Okay, let's take a look at this one right here. Okay, now I'll be the first to admit this looks awful. Not a huge fan of using 252 in a problem. Okay, but is this really that hard? It's not, because you'll notice I've got a 3, a 15, and a 252. Well, I know I can take a 3 out of both of those. So let's see what happens if we take out a 3. Can I take a 3 out of 252?
Yes.
Grab your calculator really quickly. So this is going to be x squared, this is going to be 5x, and this is going to be?
84.
Okay, negative 84. Make sure you don't make a sign mistake. Now, if you have to, you can use your calculator or you can make a list. I need numbers that multiply to be 84. Now, I could write down 1 and 84, but that would be a little silly because I'm never going to make a 5 out of the two of those. I could write down 2 and 42. Not going to make a 5. 3, does that go in there? 3 does go in there. It goes in there 28 times. 4 goes in there 21 times. This could take a while. 5 doesn't go in there. Does 6 go in there?
Yes.
6 does go in there. Okay, got quite a long list here. Okay, this is kind of a tough problem. Let's see. 6 goes in there. What would it be? 14 times? Does 7?
Yes.
7 does. 7 goes in there how many times?
12.
12 times.
There's
Can you make a 5 out of a 7 and 12? Yeah, I need to make a negative 84. I need to make a negative 84, and they need to combine to be positive 5. So 7 and 12, which one needs to be negative?
7.
7 needs to be negative, so the bigger one's positive. So this is going to be x minus 7 and x plus 12. Close the set of parentheses. Put the 3. Box that in. Make sure it doesn't disappear. Check your neighbor's paper. Just glance at it. Did they write it the way I have it on the board, or did they write the x plus 12 first and the x minus 7 second? Okay. Does it matter? No, it doesn't. Okay. Now everybody watch, please. On this problem right here, would it matter if I put the negative 5 over here with the 3 and the positive 1 with the 2?
Yes.
That would make a huge difference. That would be the wrong answer. Okay? So be careful about what you move around. You've got to be sure that you can use that commutative property. Okay. Next one. Let's take a good look at this one. First rule. Okay, what did you say, Chrissy? Excellent. Chrissy suggests we take out a negative 6x to the 4th. Taking out the leading sign helps a lot. So if I take out the negative, that's going to be a positive. If I take a 6 out of a 24, I've got a 4. That's going to be an x squared. If I take, now look at this. I'm taking out a negative 6x to the 4th. What does that do to this? I end up with a 1, and it's negative. So please make sure you're careful. Remember, we talked about this when we first started factoring. If you take everything out, remember, you're dividing out. Whenever you take everything else out, there's always a 1 left. Okay? So we're left with a negative 1, thanks. A negative 1 in this case. Okay? All right. So let's circle that and move on. What?
Different squares.
I've got 2 terms left. What is the last rule in factoring?
Factor completely.
Factor completely. Please don't forget that. Whenever you're done, take a look at this. Now, we really don't need to think about these too much, but look at this right here. We've got an x squared. Maybe we can break that down a little bit more. We've got 2 terms. We already took out the greatest common factor. If we've got 2 terms, it's a difference of squares, difference of cubes, or sum of cubes. That's all we've got. So this is a difference. Perfect square of 2x, perfect square of 1. So this is going to be first one minus the second one, first one plus the second one, and then I've got a minus 6x to the 4th sitting out front. That is the answer. Okay? Any questions there? Okay, take a look at the next one. Give you a little bit of a head start. Okay, if you've been looking at that for 10 or 15 seconds, fairly quickly some bells should be going off. And again, don't be surprised if you see something that is not in the correct order here and not in the correct order on the test. So this is not in descending order. So the first thing I'm going to do is let's rewrite this in descending order. So that's going to be m to the 6th plus 8m cubed minus 20. Now this is a trinomial. And if we were going to factor this trinomial, what would be the most logical way to make an m to the 6th? M to the 3rd here and m to the 3rd here, because that's going to allow us to make that middle term that has m cubed in it. Okay? And then at this point, even though this is more complicated than a regular trinomial, it still comes down to the same silly question. What numbers multiply to be negative 20 and combine to be positive 8? Multiply to be negative 20, combine to be positive 8. So if you think of what we typically think of, 5 and 4, no way that's going to make an 8. Tyler?
Negative 2 and 10.
Negative 2 and positive 10. So let's check that. Do they multiply to be a negative 20? Yep. And do they combine to be positive 8? They do. So I'm going to write, let's see, a minus 2 and a positive 10. Should we circle it?
Yes.
Not yet. Okay, we ought to at least think, hey, wait a minute, there are two terms here. I've got a perfect cube of m. Is that a perfect cube? No. Okay. Perfect cube of m. Is that a perfect cube? No. So we at least went through and thought about, well, maybe that's a difference of cubes. Okay. Turns out that it's not, so we'd be done right there. Okay, are there any questions? Okay, let's take a look at the next ones. Something common to all of them? No. You can skip over difference of squares, difference of cubes, sum of cubes. You can skip over perfect trinomial squares, easy trinomial, and hard trinomial. You can go right to that rule that says if you have 4 or more terms, you've got to do it by grouping. And we group to make it look like there's a common factor. So if we look through here, let's hope that it's the first two. What do they have in common?
W.
They have a W. Now, before you just blindly say, hey, I'm going to factor out a W out of the first two, we'd be left with an X minus a Y. Something in common here. A Z, we'd be left with a X and a Y. So that's, I mean, without even writing anything down, we can have a good sense as to whether or not we're on the right road. So if you take out a W, I'm left with X minus Y. If I take out, help me out here, what kind of Z? Write down the positive Z, and then we're left with an X minus Y. So I've got an X minus Y. I'm left with a W plus a Z. And there we go. Any questions? Okay, let's take a look at 70 then. I can't take out a 5. If I'm going to take something out, I might as well take out the leading coefficient, or the leading sign. So that's going to be a negative 5. I can also take out a t. If I do that, let's see, I'm left with 3t cubed. Took out the negative, so that's going to make this a negative. And that's going to be just a 2. 2 terms, perfect cubes, perfect squares. Nope. Finished. Any questions? Okay, now, 95 is going to be kind of interesting. Let's take a look at 71. Let's leave 95 alone for just a second. Okay, now, there are quite a few different ways to do this problem. Okay, could we leave it exactly like it is? No, okay, because that wouldn't be factored. Do we have any common factors?
Yes.
We have a common factor. We have a common factor of p, even as it sits right now. Okay, we could leave it like this, or we could write it as negative 64p to the 4th plus p. Keep the sign in front here with that term. So you can actually factor it this way, and you can factor it this way. Now, it doesn't really make any difference, but which way would we normally write things? Would we write them in ascending order, as it's written here, because it is written in an order, or would we write it in descending order? Probably descending order. Okay? Now, you can do both. If we have time, I'll do both. What am I going to take out here? Take out a negative p. If I do that, I'm left with 64p to the third minus 1. And I look at this. Two terms. Perfect. Okay, this has to be a perfect cube. 64 is a perfect square and a perfect cube, but p cubed, perfect cube of p. So this is going to be 4p, perfect cube of 1. And then without looking up above, the formula is, remember, if you've got two terms, that first factor is just write those two down, put the sign between them. Then we need to write down what's left. Now, the perfect, difference of cubes and sum of cubes is a little more difficult, but it's take this one, square it. Whoops, that's going to be 16p squared. Take the last one and square it. Take the two of these, multiply them together, you get 4p. Slap that right there, and what sign goes here? It's going to be a plus, because remember, there's only one negative in each formula. It's in the middle of a factor. If this was negative here, that's negative there. Okay? And the only other thing I need to do is put the minus p right here. Okay, any questions? Okay, you could do this. Take out a p, you're left with 1 minus 64p to the third. Perfect cube of p, perfect cube of 4p. So you'd have p, 1 minus 4p. And this would be 1. This would be plus 4p. And this would be plus 16p squared. Okay. Now, take a look at this. Aren't those exactly the same polynomial? Okay. Take a look at this. And take a look at this one. Okay, this is a p, this is a negative p, so they're exact opposites. What do you notice about these yellow guys? They're exact opposites also. So if you were to factor out a negative out of this and pull it out here, the 1 would be negative, like it is here, and the 4 would be positive, like it is here. Those are exactly the same thing. If I had to say which one's better, the one that we did first, the red one, is better. Okay, just because we're used to writing things in descending order. Okay, are there any questions? Okay, at the bottom of the page it says bring your book for the next few days. The test is when?
Next week.
Next Tuesday. Test is next Tuesday. Parent-teacher conferences start next week. Okay? So it'd be really nice if your parents are on your butt because you had your conference on Monday, because you have a bad grade in math. If you can say, hey, I'm going to do really well on this. I get that test graded, put the grades in on Wednesday, and by the weekend, because we have a long weekend, right? We have next Friday off.
Yeah.
Okay? By the weekend, you can come back to your parents and say, hey, you know that grade I had a C in math? Now I've got a B+. Or you know how I had a B+? Now I've got an A. Yeah.
On what day is parent-teacher conference?
It depends on who your teacher is. They're scheduled throughout the week, Monday through Thursday. Okay? You go online to schedule them. Okay? If you need help, you can see me afterward. Okay, any questions? Bring your book because we're going to be doing some story problems starting tomorrow. And the review is on Monday. So remember, the review is already online. If you want to get ahead, go to the website, go to the 1010 section, click on reviews, go to the exam 2 review. It's in the textbook. That's why I want you to bring your textbook. Okay? Yeah.
Is there going to be a test where we don't do story problems, or are all tests have to do some story problems?
Let's see, is there ever going to be a math test that you ever take again that doesn't have a story problem on it? Probably not. At least a short, easy one. Okay? All right. Great question. Good? Okay, let's take a look at this one right here. Okay, there are 2 approaches for this. I do not want you to write this down. I just want you to follow along. Okay, if you were going to do this problem, if I said, look, I'll give you $100 if you can do this in an hour. Okay, I would bet everybody here could work their way through, maybe struggle through it, maybe make some mistakes or something like that, but you could all probably do this. And this is how you'd have to do it right now. You'd multiply these together. So if you multiply these together, you get x squared plus 2x plus 1. Distribute the 3 through. This would be minus 9x and minus 9 and then minus 12. If you distribute through here and collect all the like terms, you're going to get a trinomial. Okay? It will be a difficult type of trinomial, but you could still do it. Okay? It'll have a number in front of the x squared. In fact, it'll have a 3 in front of the x squared. So that's a prime number. It's not too hard to work with. Okay? So distribute through, collect all the like terms, and then factor it that way. Okay? That's how you do it. Okay, now I'm going to show you a different way to do this. How many terms are there in this problem?
3.
There are 3. That makes it a trinomial, right? Okay, now we're used to dealing with things like this. We're used to dealing with like 3x squared minus 9x minus 12. Now, if it were that problem, could you do it?
Yes.
Yeah, but it's not. It's got this ugly mess right here. But what I want you to notice is this. Whenever we write these trinomials, every single trinomial that we've done, you can go back and look at it, we had whatever the variable part was here, this was the same variable. This was never a y and this was an x. Okay, and then we ended up being able to factor it. Okay, so here's what I want you to think about. What if I took this and I said, well gosh, I've got 3 terms. Let's just use those rules that we're used to working with. What's the first rule in factoring?
Greatest common factor.
Take out the greatest common factor. So I'm going to blow this back up. And again, you don't have to write this if you don't want, because this will be on the video. So I'm going to take out a 3. If I take out a 3, now I'm going to leave it like this. X plus 1 quantity squared. This would be minus 3, x plus 1. And this would be minus 4. Is everybody okay with that? Okay, now take a look at this pattern. This is the variable. This is the variable squared. So it's a square of a variable, then a number times that variable, and then a constant on the end, then a number on the end. So what I'm going to do is I'm going to do this, and this is a very common technique. This is called a change of variables or a substitution. I'm going to say this looks like a mess right now, but I'm going to say u is the same as x plus 1. So wherever there's an x plus 1, what can I put in its place?
U.
I can put a u. So watch. Wherever there's an x plus 1, I'm going to put a u, so that's a u squared. Wherever there's an x plus 1, I'm going to put a u, so that's a minus 3u. That's a minus 4, and I've got a 3 sitting here. Now, can't see that very well, right? That kind of covers it up. Okay, let's just look at this right here. Three terms. It's a trinomial. Can you factor that?
Mm-hmm.
Sure. U here and U here. And I need 2 numbers that multiply to be negative 4 that combine to be negative 3. Okay, it's going to be a 4 and a 1. 4 here and a 1 here. Which one needs to be negative? The 4 needs to be negative. Okay? Okay, now, that's pretty easy, isn't it? Okay, but here's the problem. We're not done. Because the original problem didn't have u's in it. It had x's in it. So what I do is, see this little blue equation here? I said wherever there's an x plus 1, I can put a u to make it look simpler. But now that I've got the answer, I can't leave the u there. I can do this in reverse. I can back substitute. I can reverse the substitution that I made. So wherever I see a u, what can I put? I can put an x plus 1. So I'm going to take this over here, and I'm going to write 3, and then it's going to be x plus 1 minus 4, and the other one's going to be x plus 1 plus 1. Now if I clean this up just a little bit, minus 3 plus 2, that right there would be the answer. Now, I'm not going to give you one like that on the test. If I did, you'd go through and you'd do it this way. You'd multiply those together, then distribute through the 3. distribute the 9 through, collect all the like terms, and you'd make a little trinomial, and then you'd factor that. And guess what? If you do this and factor the resulting trinomial, you get that right there. Okay? Now, this is a technique that you're going to learn in 1050. In fact, you learn this technique the first week in 1050. So, if you remember that now, you're going to be in good shape. You already know something from 1050. Okay, are there any questions? Yeah?
So, I know this can be kind of hard, but how would we plug it back in to check to see if we did the factoring right? If we did the 1050, not the...
If you did this?
Yes.
It wouldn't produce something that looks like this. It would produce, well, let's see what we get here. This is 3x squared plus 6x plus 3 minus 9x minus 9 minus 12. So this is going to be 3x squared minus 3x. So I've taken care of those guys right there. And then this is going to be, what do we got there? That's a 21. So that's minus 18. Is that right? My gosh, you're making me do all the work here. Minus 3 and plus 2. See how it's the same answer? Okay. So if you were going to check this, you'd multiply these together. You'd work your way to here, which would be what you got when you multiplied those out and collected like terms. Okay. Is that interesting at all? Okay, Sarah's saying no. Pretty adamantly no, right? Okay. All right. Okay. All right. You got about 10 minutes left to go ahead and log on. Get your homework done. Please be done with 5. What section is this? 5-7? Be done with 5-7 by the time you come to class tomorrow. If you're not, 2 things. It's late. And we're going to be doing story problems, applications of factoring tomorrow. And if you've got this all done and have practiced this, you're going to be in much better shape. Okay? Thank you.